Okay, now I'm going to show you a method using tables to find limits. On occasion, you're going to have a limit that when you use substitution, you'll get 0 in the denominator. And when you're first learning calculus, you won't have other tools, so then you're just kind of stuck. So one of the methods is you create a table of values and you plug in values to the left and to the right of 1 where you're getting really, really close to 1 but not touching it. So from the left, really, really close is 0.9999. And then less close is still close, but less close, 0.999, then 0.99. Now that is on the left over here. You all know what the left is, right? All right. Then on the right, well, that's more than 1. So we have 1.00, and then we match. Here's 4 place values, here's 4 place values to the right of the decimal. Here we went over 3, here we went over 3, here we went over 2, here we went over 2. So you keep it symmetrical. I guess you don't have to, but it's best if you keep it symmetrical and you get really, really close without it being obnoxious. Because really close, you'd be in the billions or trillions, trillionths or billions. I mean, this really, when you're talking about infinity, these numbers aren't very close, but they're certainly more workable. Okay, so then when you plug those values in, and I did not do it here, and I'm not going to take the time to do it here, but you would plug, let's do this one first just because it's more workable. 0.99 squared, subtract 1 over 0.99, subtract 1. Whoops. And if you're going to do that in one calculator stroke, just make sure you are careful with the parentheses. And this is what we mean by that. I'm going to move this out of the way because look at, when we plug 1 into here, normally we'd get an asymptote. But because x squared minus 1 means the same thing as x minus 1, x plus 1, and then the denominator is x minus 1, and those cancel, that just leaves this linear equation that crosses right there at 1. But remember, we still can't let x equal to 1. And what happens is when those cancel, it creates this removable point. And so I've already gone a little bit too far, but when you're first learning calculus, one of the methods that they want you to understand, and this is a great tool to have for later. If you can't figure something out, getting a table of values and to the left and to the right, picking out values very, very close, that's not a bad technique, especially if you've got a multiple choice test and they're not grading based on the work, but they're just looking at your answers. This would be a good technique to have. So this is what we mean by using a table. You look at the x value that you're, so in this case, as x approaches 1, and in the middle here, pretending 1 is in the middle, you choose 3 values to the left, 3 values to the right, plug those values into the function, and that will give you the height. And in this case, infinitely close to 1 gets us infinitely close to the value of 2. We just can't plug in 1 itself, just values close to 1. All right, that's it.